So in our last lesson, we learned about quadratic functions in vertex form. Now we're going to take a look at them in standard form. So remember, vertex form looks like this. Just to kind of review, we had that f of x equaling an a, and then x minus h squared in parentheses plus our k. And we had x equals h for our axis of symmetry, and we had hk for our vertex point. So when something's in standard form, it's going to look like this. Our axis of symmetry is still that line that divides the quadratic in half. And we find our axis of symmetry by doing x equals negative b over 2a, or opposite of b. Vertex is still highest or lowest point. And we find that, well, we already know we can find the x by using negative b over 2a. And then we plug that back into the function, whatever we get. So we will sub in the x value to find y value. And then it opens up or down. When a is greater than 0, it opens up. When a is less than 0, it opens down, just like before. And so it's a minimum if it opens up, just like before, and a maximum if it opens down, just like before. And this is that y coordinate of the vertex. So let's go ahead and try it. So kind of have a formula of that negative b over 2a. So let's identify a, b, and c first. A is 6, b is negative 12, and c is 3. So our axis of symmetry, we're going to do negative b over 2a. So negative, and then b is negative 12. 2 times a is 6. So we're going to have 12, because that turns into a positive, over 12, which is 1. So x equals 1. So we're going to plug 1 in to our function to get our y-coordinate. Y-coordinate of the vertex. So f of 1 is what we want to do. So 6 and then 1 squared minus 12 times 1 plus 3. And so we're going to plug that 1 in for all the x values. And then we're going to square here, and then it's just 6 times 1, or 6. And then this gives me negative 12 and plus 3. And then 6 minus 12 is negative 6, plus 3 is negative 3. So then I put that negative 3 here. This is a positive 6 for a, so it's going to open up, and that means that we're going to have a minimum. And that minimum is at negative 3. All right, so on this second example, we're going to go ahead and identify a, b, and c. And then we're going to plug it into our kind of formula for axis of symmetry. So opposite of b over 2 times a. So then we have a 4 over 4, which is 1. So we're going to take that 1 and plug it in to our function to figure out what the y-coordinate is going to be. So plugging 1 in here, and then we're going to square, and 2 times 1 is 2, and negative 4 times 1 is negative 4, and we're going to wind up with 3. That is our minimum, and that goes here for our y value. So this opens up because a is positive, and so that means that we have a minimum there at 3. Go ahead and try that last one and check when you're ready.